The next one, we look at example 12. Thorium-234 has a half-life of 24 days. The initial activity of this isotope is 10 microcurie. Now calculate the activity of the isotope after 72 days and time taken for the activity to fall to 2.5 microcurie. Okay, so now we have half-life 24 days. And then kita ada initial activity which is A0, 10 microcurie. So first question we need to find is activity apabila T sama dengan 72 days. So dekat sini, we are given the condition here. So kalau kita diberikan condition, remember we are going to use the activity equation, which is this one. Okay, so in order to find this A, we need to have the value for A0, which we have here, and then the decay constant, which we don't have, so we need to find this decay constant, and then the value for T, which we have here. Okay, so first of all, we need to convert first. So kena convert dahulu kepada SI unit. So half-life convert kepada SI unit sama dengan 2.08 eksponen 6 second. And then this one, A0, convert kepada SI unit, which is kena darab dengan 3.7 eksponen 10 decay per second. Okay, because 1 curie is equal to 3.7 eksponen 10 decay per second. So sama dengan 3.7 eksponen 5 decay per second, ataupun unit lain dia adalah becquerel. And then this one pun kena convert juga kepada second, which is equal to 6.22 eksponen 6 second. And then lastly, we need to find the decay constant, di mana decay constant adalah sama dengan ln 2 divided by the half-life. So half-life is 2.08 eksponen 6. So decay constant is equal to 3.33 eksponen -7 per second. Okay, so now that we have all of the information in SI unit, so kita boleh substitute the value. Okay, so the activity is equal to 4.66 eksponen 4 decay per second or becquerel, because this one is the same thing, decay per second or becquerel, so either way you can use it. Okay, so next question, we want to find the time taken. Time taken apabila the final activity, because they cakap the activity to fall to, so maksudnya final activity equal to 2.5 microcurie. So this one ada condition, meaning that we are going to use this formula. Okay, first of all kena convert dahulu. Selepas convert dapat 9.25 eksponen 4 becquerel, and then masukkan saja dalam formula, di mana A is equal to 9.25 eksponen 4 equal to A0. So A0 yang tadi, which is given here, so this one. And then okay, exponent E times with the constant, decay constant, times with t. So t will be equal to 4.16 exponent 6 second. Okay, let's take a look at example 13. Iodine 131 is among the radioactive isotopes leaked from the crippled Fukushima Daiichi nuclear power plant after the 2011 Tohoku earthquake and tsunami in Japan. The half-life of the iodine 131 nucleus is at 0.0197 days. If a sample initially contains 3 exponent 6 iodine nuclei, calculate the decay constant, initial activity and activity after 20 days. Okay, so first kita highlight dahulu information yang ada. So what we have here is we have half-life, this number, and then the initial nuclei number, which is this one. So nuclei number kalau initial adalah N0. So we have half-life, and then N0 is 3 exponent 16 nuclei. And then first question is to find the decay constant. Okay, so we know that decay constant is equal to ln 2 over t half, which is half-life. So ln 2 over half-life. So half-life dekat sini is given in days. So we need to convert to second. So convert to second times with 60 minutes times with 60 seconds. So equal to 6.929 exponent 5 second. Okay. And then just masukkan sahaja ln 2 divided by that number. So akan dapat decay constant sama dengan 1 exponent negative 6 per second. Okay, so next question is the initial activity. So initial activity is A0. So in order to find A0, we have two formula that we can use. Either we use this formula, A is equal to A0 E negative lambda T, or we can use the activity formula, which is A is equal to lambda N. Okay, kalau kita gunakan this one, okay, usually kalau kita gunakan this one is when it's given a condition. Atau maksudnya condition dekat sini adalah if it's given that T is equal to something. But we are not given the condition, so we cannot use this formula. So instead we are going to use this one. But since dekat sini we want to find initial kan, A0, bermaksud N yang digunakan, okay, dia sebenarnya adalah negatif lambda. So N yang digunakan adalah N0, which is the initial one. So okay, formula yang betul adalah negatif lambda N. So kalau kita gunakan this one, okay, kalau gunakan this one, ni bermaksud dia adalah untuk final. But since we want to find the initial, so we can use the same formula, but N dekat sini must be the initial one, which is this one. So ada given, so just masukkan sahaja negative, and then lambda is 1 exponent 6, 1 exponent negative 6, and then 3 exponent 16 nuclei. So A0 is equal to 3 exponent 10 decay per second. So negative dekat sini you just ignore. Okay, so that one is for question B, and then question C, activity after 20 days. Okay, so now dia bagi condition dekat sini. What is the activity after T is equal to 20 days? So apabila kita diberikan condition macam ni, we can use this formula. Di mana 20 days dekat sini you must convert to second. So 20 times with 24 hours times with 60 minutes 60 second. So sama dengan 1.728 exponent 6 second. So just masukkan using this formula here. A is equal to A0. So A0 yang kita sudah cari tadi adalah this one. 3 exponent 10 times with E negative, dk constant, and then times with T. T kena masukkan. Times with T, which is equal to 1.728 exponent 6. So A sama dengan 5.33 exponent 9 dk per second.